transmission electron microscopy, or a microscopy technique where an electron beam transmits through an ultra-thin specimen and a nanometer scale shadow image is taken. This is the example of the transmission electron microscope. The transmission electron microscope is a beam of electron instead of light, expecting the wave particle duality of electron. It consists electron emission source, electromagnetic lens, and electron detector. A very thin sample is positioned along the electron beam. The electron beam is produced, accelerated, and then focused on the sample by the lenses. The beam passes through the sample, which modifies it and imprints its image. The beam is then magnified by other lenses and detected, for example, using fluorescence. Transmission electron microscope allows to magnify image of very thin sample down to atomic resolution. One type of transmission microscope is the scanning transmission microscope. Here, the electron beam is focused on a specific point of the sample, not on the whole surface. The transmitted beam is then detected. A scanning of the surface allows to visualize here again and then magnifies the image of the sample. In addition, one can measure some of the transmitted beam characteristics at different locations of the sample. For example, one can measure the electron energy loss. To do so, a magnetic prism is used to deflect the beam more or less depending on its energy. The more the beam loses energy, the more it deflects. The measure of this deflection allows to characterize different parts of the sample. This technique allows, for example, to visualize but also identify the chemical nature of atoms in ultra-thin sample. In this diagram, we will show you how the sample looks at electron source and fluorescence screen. The shadow image of bismuth sulfide appears have two parts. The dark part have less electrons pass through the sample, and the light part, which means it has more electrons pass through the sample. TEM application. TEM provides structure, crystalline, and stress of substance. The image allows researchers to view sample on a molecular level, making it possible to analyze structure and texture. TEM can be used in semiconductor analysis and production and the manufacturing of computer and silicon chips. Students will have the opportunity to observe the nanoscale world in incredible deep and detail. The magnification that TEM offers are always much higher compared to SEM. TEM users can magnify their sample by more than 50 million times, while for the SEM, this is limited up to 1 to 2 million times. This figure shows image of silicon. The diagram A shows SEM image with SED offer information on the morphology of surface. The B diagram is the TEM image reveals structural information about inner sample. For the SEM image formation, electrons are captured and counted by detector image on PC screen, while for the TEM, direct imaging on fluorescence screen or PC screen with CTD. The type of electron for SEM is a scattered scanning electron, while TEM is a transmitted electron.